Hello, this is Dr. Mears, and today we are going to learn about inverse functions. First, we have to learn about one-to-one function. One-to-one function is a function where one value of x will have one and only one value of y, and one value of y will have one and only one value of x. That's why it's called a one-to-one. Here's an example of a one-to-one function. We have our little mapping here. We see that x, a value of 1 input, will get out a value of 2, which is our y value. And if we have our 2 for our output, it will be mapped to only number 1, or this one right here. So they are matched up. They're 1 to 1. Input 2, get out 4. 4 maps back to 2. So just like swans, when swans pick a partner, they stick with that partner forever. That's their one and only one partner. That's it. So 4 goes to 6, 6 goes to 4, 6 goes to 8, 8 goes to 6, 8 goes to 14, 14 goes to 8. So they are 1 to 1. They stick together forever. Let's look at not a one-to-one function. And that looks something like this. We input 2, we get out 3. We input 4, we get out 3. Now, this is a function. However, it's not a one-to-one function because this 3 now is mapped to 2 different numbers. We can't have that. 3 cannot have 2 different numbers. Same thing with 8. 6 goes to 8, and 9 goes to 8. That's wonderful. However, going backwards the other way, 8 cannot go to 2 different numbers, and that's why this is not a one-to-one function. What does a graph look like? So we have graph one-to-one function. It passes both the vertical and horizontal line test. Now the vertical line test is where I take a line, say my pencil, and I scan it from left to right, and when I scan it, you can see that it only hits the line once. So there's this imaginary vertical line, and it will only hit the graph once, only hits the graph once, only hits the graph once. Now we've done that for a function. But to be a one-to-one function, you also have to do the horizontal line test, and that's the other way. So if I drag an imaginary line from the bottom to the top, we see that it only hits the line once. So if I go this way, it's only hitting the line once here. If I go this way, it's only hitting the line once here. So through my scan, I only stay on that graph once. So it passes both of those tests. Let's look at one that doesn't. So here, this is not a one-to-one function because it does not pass the vertical and or the horizontal. So it could not pass both, or it could not pass one. Once it doesn't pass one, it's out. It's not a one-to-one. So let's look at this. If I take my pen and I scan it, I see that it passes the vertical. Okay, that's fine. That is a function. However, it's not a one-to-one function because if I do the horizontal, if I take my pen, and I pass it through, when I go horizontally, my pen touches 2 points at the same time, and you can't have that. So it passes the vertical, but not the horizontal. That's why it's not a one-to-one function. All right, let's look at inverse functions. Inverse functions is a function that reverses the action of that function. So if we think about addition, what's the inverse? Subtraction, right? They undo each other. Multiplication, division, and division, multiplication, subtraction, addition. They undo. Taking a square root of x and doing x squared. Those are inverses. Inverses are also taking inputs and outputs and switching them. I'm going to show you that in 1 second. So we're going to have some notation. The first one is the original function is f of x. So this is f of x. Just put that in for you. This is the original. Now to take the inverse, we're going to have f to the negative 1. This little negative 1 here, that means inverse. So f negative 1 of x. So this is our original. And this is the inverse. And let's look to see what happens. So I'm going to take A, B, C. That is my input. And it's going to be mapped to 1, 2, 3. A, B, C, easy as 1, 2. Now, here's the thing. When we do the inverse, look what happens. Our y now becomes our x, and our x now becomes our y. But let's make sure everything is mapped correctly. So we input A, we output 3. Okay, that's the original. Now in our inverse, we input 3, we output A. They stuck together. They just switched. Input became outputs, and outputs became inputs. So the original was XY, and the inverse becomes YX. So they switch spots. Let that sink in a little bit. Okay. What does the graph look like? So we saw ordered pairs, we saw mapping. What does the graph look like? So when we flip the X and the Y, what we're really doing is we're flipping our original over this imaginary line right here. This line is the line Y equals X. So if we took this paper, if we took this line or this curve right here, we took this curve and we folded this paper right on that imaginary line, and you can see it here. What it's going to do, it's going to flip over. We folded it, and it should look like that on the other side. And, oh, it does. So we flip it over an imaginary line. Flip over Y equals X. And what happens is we get the inverse. And so the original was XY. We flip it over, and we're going to come out with YX. And my pen is actually running out of ink. So let me get a new one. Okay, new pen. All right. Oh, we got purple. All right, so we had our original XY. We flipped it over this imaginary line. Flip. And we have the inverse, which is YX. Everything exchanges. Finding X and Y intercepts can help you to graph the inverse. So let's say that we wanted to take this original function here and graph the inverse. So what we're going to be doing is we're going to be not using this pen. Why are all my pens dying? Oh my goodness, I'm sorry everybody. Please stick with me. And all my pens are not working for me. Okay, let's try green. All right, so we're going to flip this over this. Oh, that's much better. Imaginary line, Y equals X. Try and do it as straight as possible. So if I colored this in really dark right here, and I took my paper and I flipped it over, you will be able to see the inverse. But we don't need to do that. There's such an easier way than having to flip our paper over. What we can do is locate the X-intercept right here and the Y-intercept right here. So our X-intercept is the point 2, 0. And our Y-intercept is the point up here, 0, 4. And guess what we're going to do? You got it. We're going to flip our X and our Y so that we can get an inverse. So the original X-intercept was 2, 0. The inverse X-intercept is now 0, 2. So let's plot that point, 0, 2, right here. Okay. The original Y-intercept was 0, 4. Well, now we need to do the inverse. The inverse, 4, 0. You're getting this down, so let's go to 4, 0. Okay. And so what we're going to do is we are going to draw in this little curve. Look at that. Isn't that neat? If this pen is running out too. Seriously? This pen's running out? Okay. And what you could do is you could fold your paper here and you could look to see, do they line up? And it's not really good in mine, but you can hopefully, I'll see everybody folding their paper in class to see if these two should lie right on top of each other when you fold the paper on the line Y equals X. Okay, so that is graphing the inverse. Sweet. All right, and our last page are equations. So we know that points exchange, x becomes y becomes x. We know that graphs now flip over this imaginary line. How about equations? So what we're going to do is we're going to show if two equations are inverses. And what we're going to do is use composite functions. So using the composite functions, show that if we graphed this line, f of x equals 2x plus 4, it's going to imaginary flip over and it's going to become this equation, g of x equals x minus 4. So are these inverses? So what are we going to do? We're going to first do f of g of x. That's our first one, okay? So we're going to be doing f of g of x. So we're going to be taking this g of x and we're going to be inputting it. So first, f of g of x. So we're going to take the f function and we're going to put x minus 4 over 2 equals. We're going to take the f function 2 times x minus 4 over 2 plus 4. So we took this one and in exchange of x, I put in the g. So f of x minus 4 over 2 equals, these two cross out. We have x minus 4 plus 4. These two cross out. So f of g of x equals x. Okay. Now what we're going to do is we're going to do the inverse. Yes, we're going to reverse it. Okay, so we're going to do g of f of x. So we're going to take the g function. Take the g function. And where we see the x, we're going to put the f, 2x plus 4, equals. Okay, take the g function. We have, there's our g function. In place of x, 2x plus 4. Okay, put it in. Put this one in here. Let's see what happens. G of 2x plus 4 equals, these 4's are going to cross out, so we're going to have 2x over 2. These two are going to cross out, so we're going to have g of f of x also equals x. So all in all, this right here, we have x equaling x. So our f of g of x equaled our g of f of x. And that's how you can tell they are inverses. Yay. Yes. Yay. Okay. So we have to make sure there's two different things to do. If these were not equal, they would not be inverses. They have to be equal. You do have a little bit of simplification. If you get stuck, ask me, call me over. Okay, so how do we find an inverse? So here, this is checking. This is we checked. But how do we actually find an inverse? So if I gave you f of x equals 3x plus 12, what do we do to be able to get the inverse? Well, I'm going to let you know. First, I'm going to change this f of x to y because it's just so much easier to work with. So I'm just putting y equals 3x plus 12. Now remember, in our original, it's xy. That's our original. But when we take the inverse, what happens? We flip the y and the x. And that's what you're going to do here. You're going to flip the y and the x. So instead of y, I write x. Instead of x, I write, everybody, y. Exactly. Okay, so that's the first step. Just flip x and y. Okay, that's number one. Number two, what you need to do is you need to solve for y. So here's where some solving skills. So solving for y, we subtract 12 minus 12 minus 12. We just write down x minus 12. We cannot combine them because this is an x and this doesn't have one. All right. The 3 is attached to the y by multiplication. Hey, inverse, divide by 3, divide by 3. And we can rewrite this over as y equals x minus 12 over 3. If you want to write fancy notation, this is f of negative 1 of x equals x minus 12 over 3. That's fancy notation right there. And this would be your final answer. If you kept it like that, that's fine. That's okay, because I see that you did exchange your x and your y and you solved. Don't write the f of x, but I do like fancy notation, so you should try to get used to it. All right, let's do one more. G of x equals the square root of x plus 2 minus 3. Let's rewrite this as y equals the square root of x plus 2 minus 3. Make sure that minus 3 stays away from that square root symbol. Again, right, let's exchange x and y. Okay, exchanged x and y. Now let's add 3 to both sides. Let's move that 3 over because it's just hanging out there. Rewrite x plus 3 equals the square root of y plus 2. Now, here's the thing. Learn how to work with square roots. This is not tough. Remember back in the front page I said the inverse of the square root, to undo it, we square. So if we want to get rid of the square root, we just square both sides. That square root and that square cancel out. Please remember to square both sides of the equal sign. So this one needs a 2. We're at y plus 2. One last step, you're right, we have to subtract 2. X plus 3 squared minus 2. You can't combine everything, so you're really rewriting a lot of this. The next step would be to multiply it out, but I'm not doing that yet because we haven't hit our quadratics unit. We are going to be multiplying this out in the near future, but for now, we can leave it like this. And yes, let's write the fancy way with our f of inverse of x equals x plus 3 squared minus 2. And here we have our inverse. So this has been one-to-one functions into inverses. We looked at points, we looked at graphs, we looked at equations. Hope it helped. Thanks.